Let's take up physical properties of carboxylic acid. Carboxylic acid have higher boiling point than alcohols, aldehydes and ketones, ethers because they exist as dimer due to intermolecular hydrogen bonding. This dimerization takes place in vapor state or in aprotic solvent because in water they will dissociate into ions. That is the reason that carboxylic acid are soluble in water, but their solubility decreases with increase in molecular weight or hydrocarbon part. Aromatic acids are less soluble as compared to aliphatic acids. Boiling point of carboxylic acid increases with the increase in carbon chain because surface area increases, therefore van der Waals force of attraction increases, hence boiling point. Branch chain carboxylic acid will have lower boiling point as compared to straight chain carboxylic acid because branch chain will have minimum surface area, minimum van der Waals force of attraction, therefore minimum boiling point. Melting point of carboxylic acid having even number of carbon atoms are higher than odd ones because they fit into crystal lattice more readily. So lower carboxylic acid are soluble in water, but solubility because they can form hydrogen bonds with water and also they ionize in aqueous solution. But solubility decreases with increase in molecular weight or hydrocarbon part. These are physical properties of carboxylic acid. Next, we are taking chemical reactions. Reactions can be classified into different groups. First, we are taking reaction involving cleavage of OH bond, acidity of carboxylic acid. First, we are taking reaction with metals. Sodium metal react with carboxylic acid to form sodium salt of carboxylic acid and hydrogen gas is liberated. Carboxylic acid react with sodium hydroxide. Neutralization reaction takes place. Sodium salt of carboxylic acid is formed and water is formed. With sodium bicarbonate and sodium carbonate, carboxylic acids react and liberate brisk effervescence. They show brisk effervescence due to carbon dioxide. Carbon dioxide, when passed through lime water, turns milky. Let's take up specific example. Acetic acid reacts with sodium to form sodium acetate plus half mole of hydrogen is formed. Acetic acid also reacts with zinc metal to form zinc acetate plus hydrogen gas is formed. Reaction with carbonates and bicarbonates, acetic acid reacts with sodium carbonate to form sodium acetate plus carbon dioxide and water. Acetic acid also reacts with sodium bicarbonate to form sodium acetate plus water plus carbon dioxide. This is the test for carboxylic acid. Reaction with alkalis, acetic acid will react with sodium hydroxide to form sodium acetate plus water. Acetic acid also reacts with ammonium hydroxide to form ammonium acetate plus water. All these reactions show acidic character of carboxylic acid. Carboxylic acid dissociate in water to give resonance stabilized carboxylate anions and hydronium ions. RCOOH when put in water it will give hydronium ion and carboxylate ion which is resonance stabilized, and if you are asked why carbon oxygen bond length in carboxylate ion are equal, your answer is due to resonance. And here negative charge is delocalized over both the oxygen atoms. So that's why it is more stable and that is why the carboxylic acid are acidic in nature. For the above reaction, if you want to write equilibrium constant, this will be equal to hydronium ion plus carboxylate ion divided by water and carboxylic acid. Water is very weak electrolyte, hardly dissociates into H ion and OH ion, therefore this remains constant concentration of water. We bring it this side. This constant we get acid dissociation constant which is equal to hydronium ion into carboxylate ion divided by carboxylic acid concentration. Ka is equilibrium constant, Ka is acid dissociation constant. Higher the value of Ka, lower the value of pKa, stronger will be the acid. For convenience, the strength of acid is generally indicated by its pKa value rather than Ka value. pKa is equal to minus log of Ka. If we have electron withdrawing group, they will decrease negative charge on carboxylate ion. Therefore, stabilize the carboxylate ion and strengthen the acid, that is acidic strength increases. If we have electron donating group, they will destabilize the carboxylate ion, will decrease the strength of the carboxylic acid. The effect of the following groups in increasing acidity is phenyl group has less than iodine, less than bromine, less than chlorine, less than fluorine, then cyanide, nitro, and trifluoro. This is the increasing order of electron withdrawing effect on the strength of carboxylic acid. Thus, the following acids are arranged in the increasing order of decreasing acidity. Fluoroacetic acid is stronger than trifluoroacetic acid is stronger than trichloro, which is stronger than dichloro, which is stronger than nitroacetic acid, cyanide acetic acid, fluoroacetic acid, chloroacetic acid, bromoacetic acid. Formic acid is stronger than chloropropanoic acid. Benzoic acid is stronger than phenyl ethanoic acid, which is stronger than acetic acid, which is stronger than propanoic acid. Direct attachment of the groups such as phenyl or vinyl to the carboxylic acid increases the acidity of the corresponding carboxylic acid, contrary to decrease expected due to resonance effect shown below. If we have vinyl group, pi bond of the vinyl group will take part in double bond formation, and this will stabilize the carboxylate ion. This is because of greater electronegativity of sp2 hybridized carbon to which carboxyl carbon is attached. The presence of electron withdrawing group on the phenyl of the aromatic carboxylic acid increases their acidity, while electron donating group decreases their acidity. For methoxybenzoic acid, pKa is 4.46, and if we have benzoic acid, it is 4.19. So lower the value of pKa, stronger will be the acid. For nitrobenzoic acid has got pKa 3.41, it is strongest among all these. Relative strength of nitrobenzoic acid, orthonitrobenzoic acid is strongest, pKa is 2.17, then is para-nitrobenzoic acid, followed by meta-nitrobenzoic acid, last is benzoic acid. So lower the value of pKa, stronger is the acid. Reactions involving cleavage of COH bond. Formation of anhydride, carboxylic acid on heating with mineral acid such as sulfuric acid or with P2O5 gives corresponding anhydride. These are 2 moles of acetic acid, they lose water molecule and result in the formation of acetic anhydride or ethanoic anhydride by heating in presence of H ion or P2O5, which acts as dehydrating agent. Here acetic acid is reacting with acetyl chloride. HCl is lost in presence of pyridine as a solvent. We get acetic anhydride plus HCl. Here we can use sodium salt of acid, which will react faster. Next we are taking esterification. Esterification, carboxylic acid reacts with alcohol to form an ester plus water. Esterification can be done in presence of H ions, which help in removal of water. We have to remember that in esterification, OH of acid and H of alcohol is removed. Ethyl alcohol and acetic acid react together in presence of sulfuric acid, result in the formation of ethyl acetate plus water. Let's take up mechanism of esterification of carboxylic acid, which has been asked in board exam this year. Carboxylic acid RCOOH reacts with H ion, undergoes protonation. There is lone pair of electron due to which H ion forms bond here and we get protonated acid. We reacted with alcohol R-OH and due to lone pair it starts attaching with forming bond with carbonyl carbon. So it results in the formation of bond and the positive charge now on oxygen is removed. We get RCOH, OH, and here we get protonated alcohol on this side. Tetrahedral intermediate we get, here proton transfer will take place, that is H positive ion will shift from this place to this place so that this becomes positively charged, and when this becomes positively charged water is lost. Here double bond formation takes place, we get protonated ester. Protonated ester will lose H ions and result in the formation of ester. This is the mechanism of esterification of carboxylic acid, and here it is clearly shows that OH from acid and H from alcohol is lost. Reactivity towards esterification. Formic acid is stronger than acetic acid, which is stronger than isobutyric acid, which is stronger than tertiary butyl carboxylic acid. In alcohol, methyl alcohol will react fastest. Primary alcohols are more acidic, that's why they are react fastest. And then other primary alcohols, then secondary alcohol, and then tertiary alcohol. This is the reactivity towards esterification.